Oh, dark matter is something astronomers can deduce must exist. It seems to have gravity. It seems to be responsible for our existence. After 45 mind-blowing years beyond the edge of our solar system, NASA's Voyager 1 has shocked the scientific community once again. A Nobel Prize-winning researcher has just revealed that this pioneering spacecraft, launched in 1977, has stumbled upon a discovery deemed impossible by experts. Could this data revolutionize everything we thought we knew about interstellar space? With fresh signals streaming in from billions of miles away, one thing is certain. Voyager 1's latest revelation might overshadow all previous milestones forever. Historic launch and speed. Voyager 1 had a truly dramatic start when it launched on September 5, 1977. Even though it left Earth 16 days after its twin spacecraft, Voyager 2, it ended up moving faster and soon took the lead. This was no small feat given the tight deadlines and limited budgets of the time. Scientists knew that a special alignment of the outer planets would let them use each planet's gravity to help fling the spacecraft onward, and they seized that opportunity. Voyager 1's mission was supposed to last only 5 years, focusing on Jupiter and Saturn. Nobody imagined that it would keep going for decades, let alone become our farthest human-made object in space. One especially tense moment came at liftoff. The rocket carrying Voyager 1 nearly ran out of fuel just a few seconds before it reached orbit. Had it failed, the entire mission would have ended right there on the launch pad. Yet it made it into space, and from that moment on, Voyager 1 set out on a path to become the fastest and most distant spacecraft we have ever built. It reached speeds of around 38,000 mph, vaulting past its twin. This speed helped it race through the asteroid belt, a place once thought to be too dangerous for any probe to pass, and continue far beyond the planets it was meant to study. The rocket engineers had packed Voyager 1 with instruments to survive extreme conditions, but nobody expected it to last this long or travel so far. Powered by plutonium generators, it never needed sunlight for energy, which was crucial as it zoomed farther and farther from the sun. Its speed and clever trajectory design allowed it to gather an incredible amount of data in record time. On the way, it made groundbreaking discoveries about Jupiter, Saturn, and their moons, snapping close-up images that changed what we knew about these distant worlds. But it wasn't just about going fast. Voyager 1 also carried a small piece of art and culture in the form of the Golden Record, which holds sounds and music from Earth. This tiny disk still sails through space, riding along with the spacecraft on its incredible journey. That journey all began with a daring launch, a brush with an empty fuel tank, and a burst of unexpected speed that propelled Voyager 1 into the history books. Even after so many years, its launch story remains a shining example of human courage, ingenuity, and the thrill of exploration. First close-up, look at Jupiter. Jupiter became the center of attention when Voyager 1 provided our first true close-up look at the massive gas giant in 1979. Although NASA's Pioneer spacecraft had passed by earlier, the Voyager mission revealed Jupiter in ways no one had witnessed before. From millions of miles out, the probe's cameras started taking stunning images of the planet's swirling clouds, its faint ring system, and even its largest moon. As Voyager 1 drew closer, scientists back on Earth were amazed to see Jupiter's dynamic atmosphere in greater detail. The famous Great Red Spot, a gigantic storm bigger than Earth itself, came into sharper view. Prior to Voyager, many people simply pictured Jupiter as a striped orb, but the new photographs revealed that Jupiter's clouds move in intricate swirls and eddies, with lightning-like flashes and dramatic color variations. These swirling patterns showed just how active and changeable the planet's weather can be. Voyager 1 also detected a faint ring system around Jupiter. This discovery surprised many because rings were mostly associated with Saturn at the time. Though Jupiter's rings are much thinner and dimmer, their existence proved that ring systems might be more common among large planets than previously thought. In addition, the spacecraft found 2 new Jovian moons, The and Metis, bringing more excitement to an already thrilling mission. Perhaps the biggest shock came from Jupiter's 4 largest moons, the Galilean satellites. Particularly, Voyager 1 witnessed the incredible volcanic eruptions on the fiery moon Io. In fact, this was the first time scientists had spotted active volcanoes on another body in our solar system. Volcanoes shot plumes of molten material hundreds of miles into space, reshaping our understanding of what a moon's surface could be like. Another major revelation involved Europa. whose smooth, icy exterior hinted strongly at a hidden ocean below, fueling hopes that it might harbor conditions suitable for life. All these discoveries changed our view of Jupiter forever. From wave after wave of cloud formations to volcanic outbursts, on Io, Voyager 1's encounter transformed the planet from a fuzzy disk in telescopes to a complex system filled with surprises. This first close-up look at the largest planet in our solar system did more than just gather lovely pictures. It reshaped our knowledge of planetary processes. The mission also set the stage for further exploration of the outer solar system, proving that beyond each major finding, there might be even more wonders waiting in the darkness for bold explorers to find. Volcanic activity on Io. Volcanic eruptions on Io were one of the biggest surprises revealed by the Voyager 1 spacecraft when it visited the Jupiter system in 1979. Before that, scientists thought most moons, much like Earth's moon, would be ancient, crater-pocked landscapes. Yet Io completely upended those assumptions. When Voyager 1 flew past, it captured startling images of giant volcanoes erupting and spewing hot material high above Io's surface. These eruptions shot sulfur-rich plumes hundreds of kilometers into space, proving that Io was not only geologically active, but also the most volcanically active body in our entire solar system. Much of this volcanic activity is powered by Io's special relationship with Jupiter and two of its neighboring moons, Europa and Ganymede. As Io orbits Jupiter, it gets tugged and stretched by the combined pull of these other large bodies. This constant squeezing generates enormous heat inside Io, melting rock and driving the frequent eruptions. In fact, Io has so many volcanoes that it is estimated that its whole surface is replaced by fresh lava flows every few million years. This is unlike anything we have ever seen elsewhere. The plumes themselves often take on stunning forms. In some photos, big umbrella-shaped clouds spread out at the top of the eruption kicked up by volcanic vents below. A closer look shows reddish yellow and white patterns painted across Io's landscape. These colors come from different sulfuric compounds, giving Io a colorful, even psychedelic surface appearance. Because of this, Io has been called a pizza moon, as the swirling patches of sulfur resemble toppings on a pizza. Voyager 1's discovery of active volcanoes utterly changed our understanding of how moons work. It revealed that small worlds with enough tidal forces acting on them could sustain volcanic activity. Later missions like Galileo confirmed that many of Io's eruptions reach incredible heights and vary in style. Some vent material in steady fountains while others blast out in violent spurts. Over the years, scientists have tried to model how Io maintains such high levels of volcanism. Data suggests a molten or partially molten layer deep inside continuously feeding eruptions. Even though Io lacks large amounts of water, this strong tidal heating proves that life on a moon is not just about having an energy source. There must also be the right conditions, which Io sadly lacks. Still, Io's volcanoes help us understand tidal forces, geological change, and how other moons might behave. Thanks to Voyager 1's bold journey, we discovered that our solar system still has hidden wonders, and Io stands out as a fiery little world, forever reshaping its surface. Potential ocean on Europa. Europa, one of Jupiter's largest moons, has long captured people's interest because of clues that it might shelter an ocean beneath its icy shell. The idea first arose in the late 1970s when NASA's Voyager 1 took close-up images of Europa's smooth, nearly crater-free surface. Instead of showing deep gashes from meteor strikes as on many other moons, Europa's exterior displayed crossed lines and ridges suggesting active geological processes. Scientists theorize that these cracks formed due to a layer of water or slushy ice underneath that could move and shift the crust. The possibility of liquid water caught the attention of researchers looking for places in the solar system that might support life. Water is a vital ingredient for life on Earth, so finding a hidden ocean beyond our planet is deeply exciting. Further missions like Galileo, which arrived at Jupiter in the mid-1990s, strengthened the case for Europa's buried ocean. Galileo detected hints of a magnetic field tied to Europa, something that could come from a large body of conductive fluid. This strongly indicated a saltwater ocean beneath tens of kilometers of ice. Although nobody has drilled through Europa's surface yet, the evidence has piled up over the years. Measurements of the moon's density also fit the idea of a rocky core topped by an outer shell of water or ice about 100 kilometers thick. Within that shell, many scientists think there's a deep global ocean that may hold more liquid water than all of Earth's oceans combined. Plus, Europa's core likely produces heat through tidal flexing. As Europa orbits Jupiter, it is stretched and squeezed by Jupiter's powerful gravity. This generates internal warmth, which keeps the ocean from freezing solid. Most compelling are the occasional glimpses of plumes. Some spacecraft observations hinted at water vapor jetting into space from cracks in Europa's surface. If confirmed, these plumes might allow future robots or orbiters to sample the Moon's ocean indirectly by tasting the vapor. Such a mission could reveal whether the hidden ocean contains elements essential to supporting life. Europa's possible ocean remains one of the biggest draws for space exploration. Future missions like NASA's Europa Clipper aim to fly close and map the Moon in unprecedented detail. They will test whether Europa's ocean truly exists and investigate if it harbors the right conditions for life. From cracks in ice to potential plume activity, this distant moon keeps surprising us. If water is indeed present below the surface, Europa's ocean could become a new frontier in the search for life beyond Earth. Encounter with Saturn and Titan. Saturn offered a grand spectacle when Voyager 1 arrived in November 1980, followed by Voyager 2 in August 1981. Scientists were already intrigued by the planet's wide rings, but Voyager's up-close images exposed a far more complex ring system than expected. Instead of just a handful of broad rings, there were hundreds of thin ringlets, each containing icy particles and dust. The faint fringing first noticed by NASA's Pioneer 11, only a year before, surprised everyone with its braided appearance, maintained by two shepherd moons called Prometheus and Pandora. Through its cameras, Voyager also found additional moons such as Atlas and provided clear views of previously known ones, each with its own unique story woven into Saturn's orbit. Yet the biggest mystery turned out to be Titan, Saturn's largest moon. Both Voyagers detected that Titan was wrapped in a thick orange haze, making it impossible to see the surface below. Measuring Titan's atmosphere revealed that it was primarily nitrogen, much like Earth's, but far colder and laced with other molecules that give the moon its hazy glow. In fact, Titan's thick clouds blocked all visible light images of its surface, leaving scientists with nothing but questions. Was it covered in oceans made of methane? Would there be lakes, rivers, or even a landscape shaped by liquid hydrocarbons? Voyager's data hinted that something dramatic lay beneath the fog, but no one could say for certain without more direct observations. Saturn itself still stole the show, though. Colorful photographs showed pale yellows and muted browns in its upper clouds, shaped by winds that sped around the planet at hundreds of miles per hour. The spacecraft also recorded polar regions that differed from the equatorial zones, hinting at the complexity of Saturn's weather systems. Captivating features called spokes were spotted moving across the rings, defying simple explanations. Scientists suspected that these ghostly marks might be triggered by electromagnetic forces, but the complete picture was still unclear. When Voyager 1 finished its encounter and swept behind the ringed planet, its flight path tilted it upward out of the ecliptic plane, setting it on a course toward interstellar space. Meanwhile, Voyager 2 used Saturn's gravity in a different way to continue its grand tour, aiming for Uranus and Neptune beyond. In the end, Voyager's close brush with Saturn enriched our understanding of ring dynamics, unveiled several new moons, and drew global attention to Titan's hidden realm. Those few days near Saturn remain some of the most enthralling in the history of space exploration.